Hi everyone, my name is Abhinav and welcome to the post-contest discussion of the Code Forces Educational Round 175. We'll be discussing the first four problems of the contest. So before we start, let's tell you a little bit about the newly introduced new version of the CP31 sheet. You may be knowing it. In the new version, there are 31 handpicked problems from ratings of 800 up to 1900. Okay, and every problem teaches you a unique idea. So it's a must try. And in the new version, you can even connect your Codeforces handle with the sheet. So after connecting all the submissions of your Codeforces account would be linked to the sheet, and you can just proceed with solving the sheet. Okay, so in addition to that, we'll be also releasing 7 to 8 video solutions every week. So the solutions are already being released on the TLE Eliminators YouTube channel. So you can check them out if you get stuck anywhere. Okay, so now let's start with the PCD. Okay, so we'll discuss the first four problems of the contest. Okay, so let's start with the first problem, which is FizzBuzz Remixed. Okay, so FizzBuzz is one of the most well-known problems for coding interviews. Okay, so let's ignore that. Now, let's read the problem statement, which is given an integer n, process all integers from 0 to n for every integer such that its remainders modulo 3 and modulo 5 are the same. So for every integer I such that I mod 3 equal to I mod 5, print FizzBuzz. Okay, so this problem states that if you are given an n, if you are given an integer n, then from 0 up till n for every integer, you would check if I mod 3 is equal to I mod 5. Then you would print FizzBuzz. If it is not, then you won't print. Now you don't need to solve that, but what you need to solve is given an integer n, you have to report how many times the correct solution to that problem will print FizzBuzz. Okay, so basically you need to count from 0 to n how many such I is there so that I mod 3 is equal to I mod 5. That's what the problem is. Okay, and n can be up till 1e9. Okay, so basically, if you look, you are just given an n, you are just given an n, and you need to find from 0 to n how many such I such that I mod 3 is equal to I mod 5. That's what the problem states. Okay. Now, let's suppose you are given n is equal to 3. So you would check for I equal to 0. You would check 0 mod 3 is equal to 0 and 0 mod 5 is also equal to 0. So they are same. So for that, you will do a plus 1. Now, I equal to 1. For that, again, 1 mod 3 is also 1 and 1 mod 5 is also 1. Okay, so that also satisfies. So plus 1 for that. Okay, then same way you would check for I equal to 2. Again, 2 mod 3 is equal to 2 mod 5. So again, a plus 1. And for I equal to 3, 3 mod 3, this is 0. And 3 mod 5, this is 3. So these are unequal. So you would not do a plus 1 here. Okay, so what's your overall answer? Plus 1, plus 1, plus 1. So your answer for that would be 3. Okay, so for I equal to 0 up till n, since n was 3, there were 3 possible i's for which I mod 3 equal to I mod 5. So your answer was 3. Okay, like you can look, okay, 3 is not given here, but okay, I hope you understand this was the problem state. Okay, now how do you solve that? Now, since you can see the constraints of the problem that n is up till 10 to the power 9. So you cannot do the brute force approach of checking all the numbers from 0 to n, because that would go in the order of n and this won't be accepted since n is 1e9. So you need to find some way to solve it in some maybe order of 1 or at max order of log n time. Okay, you cannot go order of n time. So instead of checking for all the I, just try to observe some pattern. Where do you get I mod 3 equal to I mod 5? Okay, let's try to observe the pattern. Now, above you can see for I equal to 0, for I equal to 0, they were equal, for 1 they were equal, for 2 they were equal, but for 3 they were not equal. Okay, let's proceed further and check. For I equal to 4, what would happen? 4 mod 3, this would be 1, and 4 mod 5, this would be 4. So again, they are unequal. Now, if you check for I equal to 5, again, 5 mod 3 would give you 2, but 5 mod 5 would give you 0. So again, they are unequal. If you check for I equal to 6, this mod 3 would give you 0, mod 5 would give you 1. So they would be unequal. So you can see like here, 6, 7, 8, they would keep on being unequal. Where do you get an equal again? If you just manually try and observe the pattern, then for 7, 8, 9, 10, 11, 12, for them you will get unequal. For I equal to 14 also, 14 mod 3 would be 2 and 14 mod 5 would be 4. So again, they are unequal. But when you go to I equal to 15, you will see 15 mod 3 is 0 and 15 mod 5 is also 0. So they are equal. So you can see what all pattern did you got which are equal. Initially, you got 0, 1, 2 for them. Your answer was satisfied. Then for 3, 4, 5, 6, 7 up till 14, your answer was not satisfied. Then you got 15. Then again, if you would check for I equal to 16, they would also be satisfied. So 16 would also satisfy your condition, and 17 would also satisfy your condition. And then you would observe that 18, 19, 20, these all doesn't satisfy your condition. Now, this was just for those who directly cannot get how it is happening. So when you just observe a little bit, you will get the pattern, and then you will get the maths. Why I'm what I'm going to tell you now, why you thought like this, because sometimes you have the question, how do you think that something like this can happen? Okay, so basically what the pattern is, if you have 3 and 5, okay, then whichever is the smaller number among the two, uh, like you have 3 and 5 only here. So among the two smaller numbers 3. So for 0, 1, 2, if you take mod 3 or mod 5, whenever you take any number mod something greater, the numbers remain the same. So they won't change. So for 0, 1, 2, your answer would be satisfied. But when you go to 3, then mod 3 would become 0, mod 5 would be remain 3. So now after 3, those for all the numbers mod 3, mod 5, they would be different. When do they become same again? They become same at LCM of 3 and 5. What was LCM? What is LCM of 3 and 5? It is 15. So when you, the first time when again the I mod 3 and I mod 5, both of them become 0. When would that happen? That would only happen for the least common multiple of 3 and 5. Okay. Their mod becomes 0 when I is a multiple of 3 or multiple of 5, then only. So I should be a multiple of both 3 and 5. The lowest number where it is multiple of both 3 and 5 is LCM of 3 and 5, which is 15. So after 0, 1, 2, the next number where they would become equal would be 15. And then for 15, again, both of the mod are 0. For 16, both the mod would be 1. For 17, both the mod would be 2. For 18, both one of the mod becomes 0, one becomes 3. So again, they are unequal. Okay. So 0, 1, 2, then 15, 16, 17. Then again, 15 into 2 is 30. So 30 would be the next number, 30, 31, 32. Okay. Then 30 plus 15 is 45. So 45, 46, 47, then 60, 61, 62. Okay, like this, the pattern would go on. These would be the numbers where you would get that I mod 3 is equal to I mod 5. Okay, I hope you got the intuition also why something like LCM of 15 was taken and why you got this pattern. Okay, anyways, once you have got this pattern, now, how do you write your answer? So if you are given n, what you need to find? Let's say you're given n equal to 23. Okay. So from this pattern till 23, how many numbers are there? How do you find that? Okay. So you can see always there are groups of 3, 3, 3. Okay. So first you will check if like n is 23. Okay. Like in how many the groups, how do you divide these groups if you try to like divide these groups? So you can see from 0 till 14, from 0 till for 0 1 2 you get 1 1 1, then till 14 you get nothing. So like you can write this from 0 to 14 you are in this group, then this group is for 15 to 29, okay, and this group is for 30 to 44, okay. So this way if you think, you could divide the numbers in blocks of 15 15 15, then among the first 15 numbers, that is 0 to 14, there are three numbers which satisfy your condition. Among the next 15 numbers, there are three numbers that satisfy your condition. Among next 15 numbers, there are three numbers that satisfy your condition. So first, for if it is n equal to 23, first see how many complete blocks you get. Okay, so before 23, this block is complete. So the number of complete blocks, for every complete block, you get 3, plus 3 to your answer. Okay. So for n equal to 23, this block is completely there. And this block is like 23 comes between this. So this block may be partially there. So first of all, the number of complete blocks are there, multiply by 3. That is your answer. Plus, for the partial block, you would check how much partial is there. So if it is 23, which is like from 15 to 23, there are more than three numbers. So 15, 16, 17 would obviously come there and you add a plus 3. But if it was n equal to 16, then till 16, only two numbers, 15 and 16 would come. So you would add only plus 2. And if n was 15, then only one number would come there. So you would add only plus 1. Okay. So what I can say is my final answer would be, I can write a formula. How many complete blocks do you get? That would be n by 15, you can say. Why? Because if it was 23, like from 0 to 14, if you do n by 15, then from 0 to 14, if the n is from 0 to 14, you would get 0. Because if you are in this range, you have 0 complete blocks. Once you move to 15, n moves to 15, n by 15 would be equal to 1. That means one block is present completely. So from 15 to 29, your n by 15 would be 1. From 30 to 44, n by 15 would be 2. Okay, so likewise. So n by 15 would give you the number of complete blocks. Okay, it's integer division. Okay, this multiplied by 3 would be the contribution of the complete blocks. And then plus in the current block, how much do you get? Okay, so n modulo 15 would give you the size of the current block. You can see if n was 15, n modulo 15 would be 0. Okay, so n modulo 15 plus 1 you can say. So n modulo 15 plus 1 would give you the how many values are there in the current block. So if n was 15, n modulo 15 is 0 plus 1, 1. So only one number is there in current block. If n was 16, then n modulo 15 plus 1 would give you 2. Okay, so this is 1 plus 1, 2. So there are two numbers in the block. So you can say plus n modulo 15 plus 1. Okay, so it would be this, or if there are more than three numbers, then only 3 would get added, because after 3, after 15, 16, 17, if n is 18, then n modulo 15 plus 1 would be 4, but you would only add plus 3. So you can say this is minimum of either this or 3. Okay, so I can write my final answer like this. I hope you understood how I got this. So in O of 1, you can just compute your answer using this formula, n by 15 into 3 plus minimum of n mod 15 plus 1 or 3. Okay, I hope this is completely clear to you. So my code would be very, very simple. I just need to write, just input your n, and answer is n by 15 into 3 plus minimum of n mod 15 plus 1 or 3. Okay, and just print your answer. Okay, what would be the time complexity? It's simple, O of 1. Okay, and so time complexity is simple, O of 1, and space complexity is also O of 1. You only take the O of 1, you only take the integer n. Okay, so I hope the first problem is clear to everyone. We can move on to the next problem. Okay, so for problem B, what is given? There is a robot on the coordinate line. Initially, the robot is located at the point X. The robot has a sequence of commands of length n consisting of characters where L represents a move to the left by 1 unit. So if you are at P, you move to the left and move to P minus 1. R represents move to the right. So if you are at P, you move to B plus 1. Okay. The robot starts executing this sequence of commands. However, whenever robot reaches the point 0, the counter of executed commands is reset. That is, it starts executing entire sequence of command from the very beginning. Okay, so the robot is initially at some point X, and then it executes some sequence of commands, which is either move to the left or move to the right. Okay, so it starts executing a sequence of commands, and once it starts moving, if at any point it reaches the point 0, then all the executed commands are reset and it again starts executing from the start. Okay, so there is some sequence of commands. If it reaches 0, then it again starts executing the commands from the start. Okay, and then if the robot has completed all the commands and it is not at 0, then it just stops there, stops executing any more commands. It remains there. Okay, and one command is executed in 1 second. Okay, so one command per second. So you need to calculate how many times the robot will enter the point 0 during the next k seconds. Okay, so in the first k seconds, you need to find how many times the robot would be at point 0. Okay, so basically, I hope you understood the question. So let's take this example and understand. So you are given n, x, and k. So this is n, this is x, this is k, and a string s. Okay, so this string s just denotes the sequence of commands that you can execute. Okay, so what does this mean? It means x is 2. Okay, so on the number line, the robot is initially at point 2. Okay, so since x is 2, the robot is initially here at point 2. Okay, now it starts executing some sequence of commands like this. Whenever it reaches 0, it just resets. Okay, so after 6 seconds, you need to find how many times the robot reaches 0 in the first 6 seconds. Okay, so at t equal to 1, the robot is here. Okay, so at t equal to 0, the robot is here. Okay, after the first second, it executes this command and moves to the left. So now the robot is here. Okay, so now the robot is here at t equal to 1. Okay, next second, it executes this command and again it moves to the left, and now the robot is here. Okay, so at after 2 seconds, the robot is here. Now since the robot reaches 0, it would reset all the commands, so it would start executing again from the start. Okay, so in the next second, again it moves to the left and the robot reaches here. So after 3 seconds, the robot is here. Okay, and then it executes this left command. It again moves to the left and the robot is here after 4 seconds. Okay, and then it executes this command. So it moves to the right. Okay, and now the robot is here after 5 seconds. So after that, all the commands are over. It reaches to the end of the commands and it is not at 0. So it would just stop there. So even after 6 seconds, 7 seconds, 10 seconds, or any time, it would just stay here. So how many times in the first 6 seconds did the robot reach 0? It was one time when it reached here, and then it just, okay, so it started here, it moved here and came back here. So only one time it reached the point 0. So your answer would be 1. Okay, so for the first test case, you can see the answer was 1. Okay, so I hope you understood what you need to do, what the problem states. Okay, now if you look at the constraints of the problem, again, k is up till 10 to the power 18. Okay, n is 2e5, x is less than n, but k is 10 to the power 18. So if you just simulate this process for k seconds, then you cannot do it, solve this problem in order of k. So the brute force approach was just simulate this process, but that would take a complexity of order of k. So how do you solve it in a little optimal way? So your n is 2e5. Okay, so at max, what would happen? This whole command of length n would get executed and the robot would stop. Or there would be a loop where some of these commands are executed and it reaches 0, again that command is executed, it reaches 0, again that is it. So when you come to that loop, you can just calculate that what is the time that loop is taking, and divided by the remaining time, you get the number of times that loop is executed, that many times, so 0 comes. Okay, so this one initial logic you can get. Okay, but that loop would not start initially, because initially you are at a point X, not 0. Okay, so if you just check the first time when you reach 0, that doesn't create a loop. But once you have reached 0, after that, if you reach 0 again, then you got a loop, that the first from X when you reach 0, okay, that time you can just calculate manually by simulating the process, that in how much time would you reach 0. Once that is done, after that, from 0, you start again from the start. And then if you reach 0 again, then the time that it takes, this thing would just keep on repeating. Okay, so what I'm telling, like, if in the number line, this is the point 0, and let's say this is the point X. So first from here you would start, you would do some set of uh, instructions, and maybe at a point you reach 0. Okay, so you moved from X, you started, you moved left, right, some right, left, and all. And then you finally, after some point, you reach 0. Okay, let's say you took t1 time to reach 0 from X. Okay, so after, I'm telling, after t1 time, you reach 0 from X. Okay, one case would be that this t1 is greater than k, you are taking more than k time, then you would just say that you, in the first k seconds, you never reach 0. Okay, you can just return 0 as your answer if this t1 was greater than k. Now let's suppose this t1 was less than k, so after t1 time you reach 0. So now for the remaining time, what would happen after you reach 0? So in the given string S, for the given some instructions. Okay, so in t1 time, let's say you executed the first t1 instructions. Okay, after executing the first t1 instructions, you reached 0. So you again start with the first instruction. So when you start with the first instruction, after that again you move left, left, something you move, and you come back to 0, let's suppose. Okay, so after executing some set of instructions, let's say after a time t2, okay, in time t2 you executed some set of instructions. So at time t2, after time t2, when you started with 0, you came back to 0 after t2 time. So then what you would say, that after time t2, you started with 0 and you came back to 0. Then this same thing would happen again and again for the next t2 seconds. Again, this exact process would get repeated. Next t2 seconds, exact process would get repeated. So I hope you understand, because you had started with 0 and you came back to 0 in t2 time. Again, when you came back to 0, you start from the first instruction. So again, same thing would happen after exact t2 time, you would come back to 0. So what you can say, how many times did you reach 0 in the first k seconds? So first you took t1 time to reach to 0 for the first time. And so k minus t1 would be the time remaining. So in the remaining time, how many times again you came to 0? Would be in every t2 seconds, you come to 0 once. So this divided by t2 would give you the number of times you come back to 0. Okay, and for the first time when you came back to 0, for that you can add a 1. Okay, so I think if you compute these two times, that where I'm telling that t1 is the time taken to reach from X to 0, and t2 is the time taken to reach 0 to 0, or you can say to come back to 0 if you start with 0. So then if you compute these two times, then you can say that your final answer is 1 plus this, if this t1 is less than k, less than if this t1 is greater, yes, less than k, or even if it is equal to k. Okay, So if this T1 is less than equal to K, then your answer is this. And if this T1 is just less than K, then your answer is simply 0. I hope you understand, because you cannot reach to 0. You are reaching to 0 after K seconds for the first time. So in K seconds, you are not reaching 0 anytime. Okay, so I hope now it is clear. So you just need to compute this T1 and T2, and you can write your answer like this. Okay, and how do you compute T1 and T2? Just simulate the process. So start with X and just simulate the process until you reach 0. Now, this T1 time would definitely be less than equal to N, because after n seconds, if all the n instructions are executed, the robot just stops there. So if after n instructions you don't reach 0, just return 0, that you would never reach 0. Okay, so this is only valid if you reach 0 in the first n seconds till n instructions are executed, because after n instructions you just don't have any more instructions. So this T1 calculation would take at max an order of n time. Okay, and this T2 calculation, again same thing. If you start with 0 and you have to come back to 0, at max you would execute n instructions. You cannot execute more than n instructions. If it is taking more than n instructions, you would just stop at some random point and never come back to 0. Okay, so that again, in that case also, you will say that your answer is 1 the first time you reach 0. After that, you never came back to 0, so the answer would be 1 in that case. Okay, so this would also take at max an order of n time. So overall, in order of n time only, you are able to solve this problem. I hope this thing is clear to you. Okay, and I have written what was T1 and T2. I think it's clear. If you have any more doubts, you can ask, or we'll move to the let's move to the code part. Okay, so I took the input nxk and the string s. After that, first I'll try to calculate how much time do it take to reach from x to 0. Okay, so for that, what I'm doing, I'm initial position is x, so I'm just changing that position only. So if I encounter a left, then I do x minus minus, otherwise I do x plus. Okay, so this way I'm just moving my pointer, and I'm doing k minus minus. So like finally what I had to do, I had to subtract t1 from k. So whatever time you are taking, that is subtracted from k. Okay, so that I'm doing here only. Instead of computing t1 in a, you can just compute t1 in another variable also. So it's just about how do you write the code. So I'm doing k minus minus here only. So when I come out, my k would be updated to k minus t1. Okay, and if I reach 0, if the x becomes 0, then I just took a Boolean variable that whether I reach 0 or not. It may happen that after n instructions, I come out of the loop and I haven't reached 0. So just to handle that case, I take a Boolean variable, assign it to 0. If I encounter a 0, I make that Boolean variable 1 and break out of the loop. Okay. And if during the process, I see that k becomes equal to 0, that just means this t1 was greater than k. Okay, so even in k seconds, I'm not able to reach 0. So there only I'll just return 0. I'll just output 0 and return out of my function only. So my final answer is 0. So if this k becomes 0, that in first k seconds, I'm not able to come to 0, then my answer becomes 0. And if this f remains 0, that means I never encounter x equal to 0. So if this f remains 0, then also my answer would be 0. The robot would just stop after n instruction and it would never reach 0. So these base cases are handled. Now, after this, if I'm moving, that means I have reached 0 and this k is now updated to k minus t1. Okay, now I need to just find out this time t2. Okay, so this time t2 I'm calculating in this variable t. Okay, so now my answer is 1. I've initialized this answer with 1. Okay, to that I'll add this after computing t2. Now I'll try to compute t2 now. So I'll move, and if that's I get L, I do x minus minus, otherwise do x plus plus, and I keep on doing t plus plus. So for every step I do t plus plus, this way I'll compute the time. Okay. And now I started with x equal to 0 because after running this loop, x had become 0. Okay. If x was not 0 after running this loop, I would just see out 0. So if I'm coming here, that means my x is already 0. I don't need to initialize it to 0 again. Okay. So now I'll just simulate the process. If the x becomes 0 again, then okay, I made the Boolean variable 0 again, and if x becomes 0 again, I made the Boolean variable 1 and break out of the loop. Okay, so my x is now again 0. So if if f is 1, that means if x becomes 0 again. Okay, so if f doesn't become 0 again, then what would happen? If f is 0, then my answer would be just 1, that I reached 0 initially. After that, I again never came back to 0. Okay, so in that case, my answer would remain 1. But if I'm able to get to back to 0 again in less than n time, then I would get some t. So I'll add k by t to the answer. Okay, so as I shown in the formula, this k is now updated to k minus t1 from my initial loop. So adding k by 2 would give you my final answer. And then I print my final answer. Okay, I hope the code is clear. What if I encounter 0 before k turning 0? I hope that is clear to you now. You were asking about the first loop, that what if I encounter 0? Yeah, can you repeat once? You're asking about this initial loop, right? Okay, so if I encounter a 0 before k turning 0. So if I encounter a 0, if x becomes 0 before k turning 0, then I just write f equal to 1 and break out. That means I just computed. So I started with x, then after some operation, my x becomes 0. My current position becomes 0. So I'll just take the time that I took in coming to 0. That's what my t1 was. So I'll just break out of the loop, and whatever is the time, my f is 1, so this won't be executed. So I'll just proceed further with calculating the other part of my answer. My k is subtracted by t1. Okay, so t1 times my k got subtracted, and I'll just proceed calculating the other answer. Seeing that when if k is becoming 0, then y answer is 0 directly. Okay, so if k is becoming 0, that means I started from here, and after k seconds, I'm at some point and I have not reached 0 even once. So if this loop gets executed k times, k would become 0. So even after running k instructions, if I never encounter x equal to 0, then that means after k seconds, I never encountered a 0. So my answer is 0. How many times did I reach 0? It's 0. Okay. So I hope this is clear to everyone now. If there is any more doubts, you can ask. And if you analyze the complexity, this I'm running a loop n times at max. These are all if else conditions O of 1. So this is order of n here. This is if condition. Okay, then this loop is running n times, and these are just if else conditions. So this is at max order of n again, and these are if else conditions. So overall, my time complexity would be order of n, and my space complexity would be, I'm just using a string of size n, and I think the normal variables only. So this string of size n is taking the order of n space. Okay, so I think we can move on to the next problem if nobody has any more doubts in this. Okay, so let's move on to problem C, which is limited repainting. Okay, so you are given a strip consisting of n cells. All cells are initially colored red. In one operation, you can choose a segment of consecutive cells and paint them blue. Before painting, the chosen cells can be either red or blue. Note that it is not possible to paint them red. You are allowed to perform at most k operations, possibly 0. Okay, so basically you are given n cells which are initially all red, and in every operation you can select a segment of consecutive cells and paint them blue. But you can never, once you have painted a cell blue, you can never paint them back to red. Okay, you can only paint cells from red to blue. You cannot do the reverse. Okay, so you can select a segment, paint it blue, select a segment, paint it blue. You can perform this operation at max k times. For each cell, the desired color after all operations is specified red or blue. It is clear that it is not always possible to satisfy all requirements within k operations. So you are, for all the n cells, there is some requirement that this cell should be red or this cell should be blue. Okay, so it may not be possible to satisfy all the requirements in k operations. So if there is also a penalty specified, which states that if a cell ends up in wrong color, then you would have a penalty for that. And the penalty is given as AI. So for every cell, if it ends up in wrong color, there is some penalty given to you. The final overall penalty is maximum penalty among all cells that are painted wrong color. Okay. So among all the cells that are painted wrong color, among all those penalty, whichever is the maximum, that's your overall penalty for the game, you can say. So, and if there are no such cells, if you are able to paint all the cells as per the requirements, then your penalty would be 0. So you need to find what is the minimum penalty of the final painting that can be achieved. Okay, so I'll explain you with the first example. Okay, so you are given, so this is n and this is k. You are given a string which denotes the desired color of your strip, and you are given an array A which denotes the penalty for every index. Okay, so let's take, say I'm taking 0 based indexing. Okay, then what does this mean? So initially you have, what do you have is n is 4, so you have 4 strips. Okay, so initially all the strips are painted red. Okay, initially you have this state. Now what you want is this blue, red, blue, red. Okay, so what you want is blue, red, blue, red. Okay, so you want this state to change to this. For that, what you can do, in every operation, you can maybe select a range of cells and paint them blue. Okay, so let's say you selected this range of cells, then they would become blue. Okay, so this is the operation that you can do. Okay, k is given 1, so you can only do this operation at max 1 time. Okay, so whatever is the value of k, if k is 3, you can do this operation 3 times. So in after that many operations, you want to bring this as close to this as possible. Okay, wherever it would differ, that would give you a penalty. So let's say for this, what we did is, we have only one operation, so maybe we selected these 3 cells, okay, and painted all of them blue. Okay, so this would become blue, this would become blue, this would become blue. Okay, once this is done, okay, now my one operation is done, so I cannot do any more operations. So this would be my final strips. So now let's calculate the penalty. How would the penalty would be calculated? First, you'll see this. Both of them are safe. First, same. The first strip needed to be painted blue. It is blue, so no penalty for that. Second strip, it needed to be painted red, but it is blue. So this would give you a penalty of 3. Okay, so this would give you a penalty of 3. Third, it was expected to be painted blue and it is blue only. Fourth, it was expected to be painted red and it is red only, so no penalty. So overall, there was only one cell which was giving you some penalty, and that was this second cell. It gave you a penalty of 3, so your final overall penalty would be 3. If there are more than one cell which is giving you a penalty, then the maximum among those penalties would be your final penalty. Okay, so you needed to minimize this final value. So you need to select this operation optimally so that the final penalty that you get is minimum. For this case, selecting this strip was most optimal. It gives a penalty of 3 only. The other way was, let's say you were initially all of them were red. Okay, let's say you applied an operation on this and changed this to blue. Okay, then what would happen? For first cell, it is blue, fine. Second is red, fine. third was expected to be blue, but it is red. So this would give you a penalty of 5. Okay. And then fourth, expected to be red, it is red only. So your overall penalty is 5 in this case, but a better way was paint like this and get an overall penalty of 3. So your final answer would be the minimum that you can get, which is 3. Okay, so here final answer was 3. Okay, and if two operations were allowed here, it is the same question which with k changed to 2. Then what you could have done, you could have just, after performing an operation like this, you could have performed a second operation in this and change this to blue. Okay, that way you would get blue, blue, red, red, blue, blue, red, red. Okay, so you got what was needed. So your overall penalty would be 0 here. You were able to get everything as it is. So your overall penalty is 0. Okay, I hope the problem is statement is clear to you now. What you need to do. Okay, let's try to think how can we solve this problem. Okay, if you look at the constraints, n is 3 into 10 power 5 and k is less than equal to n. Okay, so you need to solve it in some order of n or n log n, something like that. Okay, so the first observation for us is when you have to paint some. Okay, first of all, let's try to find when can our answer be 0. That is, when can we make all the requirements fulfilled. Okay, so initially what you have is a strip with n cells, okay, all of which are painted red. Initially it is like this. Okay, what you want to make it, let's say that you have the string s, it is something like red, red, blue, blue, red, 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 blue, 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 red. Okay, something like that. So what is, first of all, if you are just asked what is the minimum number of operations you would need to convert this string to this, what would be that? So in one operation, what you can do is select a basically a strip. Okay, just select from this array, just select a sub array, you can say, and select a segment and paint it blue. Okay, so if you have to make it something like that, so first two need to be red, let them be red. Then the next two need to be blue, then some patches of red, then some patches of blue. So you'll just see how many groups of blue do we have. Because whenever you do the operation, how would you do the operation if you have a strip, okay, which is all red? You'll select some segment painted blue. Again, you'll select some segment painted blue. You may also select some overlapping segment and painted blue. But does it have any benefit? If you are selecting this segment and then you're selecting this segment, you could have directly selected this whole segment and painted all of them blue in one go. So this is never optimal. This is never optimal to select two overlapping segments. So always you will select non-overlapping segments. Okay. So if you have to paint it all blue, you'll select it in one go. So basically, whatever string you are given, the minimum requirement, the minimum number of steps needed to paint it all blue would be, just see how many groups of blue do you have. Here all red, red, red. Okay, so you have all red, red, red. Then you have two blues. Okay, then these are red, red, red. Then you have two blues, three blues, and then red. Okay, so here we have one group of blue, here we have one group of blue. So for this case, you can see if you have two operations, then you can just make this strip exactly like this. Color these blue, okay, and then color these blue. Okay, the strip would become exactly as it is desired. So if k is less than if k is more than 2, then your answer would be 0 in this case directly. Okay, so this is the first observation that you get. But what if k is less than 2 here? Okay, or if you had, let's say, one more blue red here, this would be blue, this would be red. So how many groups do you have here? 1, 2, and 3. 3 groups. So k should be at least 3. You need at least 3 operations to make it exactly like this. So here if k is given 2, that means you cannot make it exactly like this. So you would encounter some penalty. What is the minimum penalty that you get? Okay, if you try to think. So the first thing is, if you want to do it optimally to get the minimum penalty, what is your penalty basically? It is the maximum among all the penalties, maximum among all the I where the final color is not same as desired color. So for all those I, you take the maximum of AI. Okay, so your array A is given. So for all the positions where you are not able to not able to color it same as desired, the maximum among those AI values is your final penalty. So, and you need to minimize that. Okay, so whenever you get a problem, something like that, where you have to minimize the maximum thing, one thing that should come to your mind whenever you get to minimize the maximum, okay, or maximize the minimum. If there is something like this task you have to do, one normal intuition is binary search. I hope you know that. Okay. If you don't know, you can just recognize now. From moving forward, whenever you see something like this, the task you have to do is minimize the maximum or maximize the minimum. Binary search is the most common way to do that. Okay. So by binary search, what I mean, you have to do the binary search of answer. Basically, let's if you apply binary search on answer, what it would become. So by what do you mean by binary search on answer? So you are assuming that your answer is mid. Okay, whatever in binary search, whatever mid you get, you are assuming that is your answer. If that is your answer, you will try, can this be my answer? If yes, then okay, I'll try to minimize it more. I'll move high equal to mid -1. Okay, and if the answer is no, then I'll say I'll increase my mid to satisfy the answer. So now your only task is to create that check function which checks. So you need to check. So check mid would check, can my answer be mid? Okay, or let's say right, check X. You need to just create this function which checks, can my answer be X, and then apply binary search using this check function. You will get your final minimum answer. Okay, now how do you create this check function? Can my answer be X? Okay, so if I'm assuming that my answer is some X, okay, let's say X is 10. Okay, if I'm assuming that my final answer is 10, that means for my answer to be 10, I should not have a penalty of more than 10. Okay, if I have a I for which AI is more than 10, then I need to make sure that this is same as what color is desired from it. Because if I encounter a penalty of more than 10, then my overall maximum penalty would be more than 10 and my answer cannot be 10. So in order to restrict my answer to less than equal to 10, I know just for all the indexes, I know for those indexes where AI is greater than X, I'll say that I have to make sure that it satisfies the color which is required. And for all those indexes where AI is less than X, I don't care whether it satisfies my condition or not. Okay. So once you know that, so inside the check function, what I'll do is just for all the indexes, instead of this RB, all those index where AI is less than equal to X, I'll convert that to maybe a don't care situation. Like instead of RB, maybe I replace it with that I don't care about this. It can be anything red or blue, it doesn't matter. It won't affect my answer. Okay, so all those where it doesn't matter, AI is less than X, I'll convert that to don't care. Okay, let's say some of them got converted to don't care. And then I'll look at this string again. Okay, now what is the minimum number of operations needed to convert it to this, where I don't care about wherever I have a don't care condition, that can be blue or red, doesn't matter. But wherever I have a red, that should be red, blue should be blue. Now, if you have something like this, how do you find the minimum number of uh, operations needed? If that minimum number of operations is less than equal to k, then I return a yes from my check function. Otherwise, I return a no. Okay. Now, how do you check this? Okay, for something like this, here again, in order to make it like this, so whenever you have a don't care, maybe consider it as white, like it can be anything. So just ignore that. You can say just ignore these strips, and after ignoring whatever string you get, in that apply the same thing that I initially told you. Just see how many groups of blue you have, that many operations would be needed. So if you look like this, here you have red, red. Okay, so I'll change this now. So you have red, red, then this is blue, this is don't care, then red, red. Okay, then these are blue, 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 and this is also blue. So now if you saw, there we have a one group of blue, and here this is a single group of blue, because in the middle when we have don't care, just ignore them. So this becomes a single group of blue. Now for this, I'll say 1 and 2, only two operations are needed to convert this to this. Okay, so if 2 is less than equal to k, I'll return a yes, otherwise a no. So I hope now the logic is clear what you need to do. How do you check these groups? Just start. If you have initially red, just ignore it. Whenever the first time you get a blue, then add a +1 to your answer. Now, until you are getting blues, just continue. Once you get a red, again, once the color changes from blue to red, okay, so that group is over. First group is over. Again, when you get a color change from red to blue, add a +1 to your answer, you start a new group. Again, when you get a color change from blue to red, okay, that group is over. So the number of color changes from red to blue, that is the number of operations required, you can say. Okay, so I hope this is now clear to you. So what would be the overall complexity? The upper binary search would take a login time, and this check function, I'm just iterating through the whole array once. Okay, wherever I have AI less than equal to X, I'm just ignoring that and moving forward. So that way the check function would be order of N, and a binary log N extra for binary search. Overall time complexity would be N log N, and that would be accepted. Okay, I hope the logic is clear to you now. We'll move on to the code. Okay, I took the input N, K, and the string S and the array A. Input part is done. Then I apply binary search. Okay, what would be the range of my binary search? If you look, the minimum my answer can be, that can be 0. If no penalty is incurred, my answer is 0. So my answer can be 0 at minimum. At maximum, what can be my answer? AI is at max 1e9. Okay, so the maximum value, maximum penalty I can have is 1e9. Okay, the maximum of all the AI can be at max 1e9. So I set my high as 1e9. Okay, you may take 2e9, 3e9 for safety if you wish. Okay, so my range of my answer is this, from 0 to 1e9, and I just initialize my answer variable. Then I apply binary search, low less than equal to high, mid is low plus high means low by 2. And now I just count. I just apply my check function where I count the minimum number of operations required to convert it to basically for my given array with a given value of mid, or which I'm telling as X, how many minimum operations are required. So how many times I'm changing from red to blue is what the minimum number of operations required is. Okay, so how do I check this? If AI is less than equal to mid, I just ignore it. Just continue. Okay, and then this what I've written here is my F denotes the current color. So F equal to 1 denotes red. So F equal to 1 denotes red, and F equal to 0 denotes blue. So currently, initially when I'm starting with, I'm telling my color is red. The first time I get blue, from there, my color changes to blue, that one segment of blue starts. Okay, so when you, so this XOR F, or you can write in AND OR form also, what it means that if the current color is red, this would return a true 1, and F is 0. It means blue. So if previously it was blue and now it is red, or if this is returning false, then currently my color is blue and previously it was 1 red. So this would become only true if this is 0 and this is 1, or if this is 1 and this is 0. Okay, so you can write this in the form of and or if you feel it simpler. So I just wrote it in the form of or whatever. So this just denotes that I'm getting a color change from red to blue or blue to red. So whenever I get a color change, I just flip my F. If F was 1, it would change to 0. If it was 0, it would change to 1. And in my count, I add F. So if my previous color was red and I'm changing to blue, then I would add +1. So if my previous color was red, then I add a +1. If my previous color was blue, I'm changing from blue to red, I don't add a +1. So I hope you can understand from here. Whenever I'm going from red to blue, I add a +1. Whenever I go from red to blue, I add a +1. If I'm going from blue to red, I don't add a +1 because I'm just counting the groups of blue. Okay, so this way I'm able to, in my count variable, I get the minimum number of operations required to get mid as my answer. If this is less than equal to k, then my answer is mid, and I try to minimize it further by I equal to mid minus. Otherwise, I try to increase my mid, increase my range so that I get the answer low equal to mid plus. Okay, and I just print my final answer. I hope the code is clear to you. What if we are asked to minimize the sum of penalty? Yeah, if it is sum of penalty, it's a whole different question altogether. And actually, what during the contest, what happened is I just misread this problem actually to be as sum of penalties only, and I was trying to solve that problem only, and it was just not possible to do it in O of n. It was going n square using dp, and then I just read the problem and again, and it was maximum. So like you can see, I solved this problem at the end after solving the d problem because I had misread this problem to exactly this what you are asking, as if this question is sum of penalties. So yeah, if it is sum of penalties, then I think there is no O of n solution to that. It may require an O of n square, but okay.
If it is sum of penalty, can we do it in the n order of nk by finding the maximum subarray sum k times?
Yeah, you can do it in order of nk. Like I thought using dp, but I think what you are telling using maximum subarray, maybe through that also you can do. Yeah, in order of n into k, it was achievable to do if the question was sum of penalties. But okay, maybe if you want to discuss about that, we'll discuss at the end. But this was the problem that was given to us, and this is a solution. I hope this is clear to everyone. Is there any doubt in this? If you look at the time complexity, this whole for loop, the check thing is running in order of n time, and this is a binary search which would take at max, which would run at max log n time. So this is overall and log n. So I can say my overall time complexity is order of n log n, and my overall space complexity is you are just using this input vector of size n, so order of n. Okay, I hope this problem is clear. If anybody has any doubt, please ask, or we'll move on to the next problem if there are no doubts. Okay, so I think we'll move on to the next problem now, which is problem D, tree jumps. Okay, so you are given a rooted tree consisting of n vertices. The vertices in the tree are numbered from 1 to n, and the root is the vertex 1. Let dx be the distance, the number of edges on the shortest path from the root to the vertex x. Okay, so you are given a tree with n nodes, and it is said that it's rooted at the node 1. Okay, and dx just denote the number of edges in the shortest path from root to x. So you can notice for any node, the shortest path from root to x would is dx. So it is actually in the terms of tree, if you know, it's the depth of the tree node. Okay. So if you just divide this tree in depth wise or level wise, whatever you say, the level of the node or depth of the node is dx. Okay. Now, there is a chip that is initially placed at the root. You can perform the following operation as many times as you want, possibly zero. Move the chip from the current vertex to the vertex u such that du is dv plus 1. Okay, so there's a chip which is initially at root, then you can move it to any other vertex which is which has a depth just greater than 1. If the chip is currently at a vertex u, it has a depth at a vertex v which has depth v, then it can be moved to vertex u which has just one depth greater than that. Okay, so just one level below. If v is the root, you can choose any vertex u meeting this constraint. However, if v is not the root, u should not be a neighbor of v. There should be no edge connected. Okay, so what does this mean? It means like if this is your v, if the point is currently here, then you can move to okay, so this is at the first level, this is at the, like if you divide it in levels, okay, these would be the levels. This is third level, this is fourth level. Okay, depth level, whatever you say. So if you are at the this vertex 1, if you are at the root, then you can move to any node in the next level. It doesn't matter. But if you are at any other node, if your v is any other node other than the root, then the next vertex where you move should not be adjacent. Okay, there should be no edge connecting you and you. So if you are at 5, you cannot move to 7 next, but you can move to 4 or 3 next. Okay, and if you are at 2, you cannot move to 3 or 4, but you can move to 7. That's what this statement states. Okay, now if that is clear, so for example, okay, this example that is explained. A sequence of vertices is valid if you can move the chip in such a way that it visits all vertices from the sequence and only them in the order they are given in the sequence. Okay, so you'll say that a sequence is valid if you can create this sequence by moving the chips. Basically, if I'm telling the sequence is 1, if I'm telling the sequence is 1, 2, 7, that sequence would be valid if you can create this. If you are at 1, next you can move to 2. Okay, after 1 you move to 2, then you can move to 7. Okay, then this sequence is valid. But if you have something like 1, 2, 6, so after 1 you can move to 2, but from 2 you cannot move to 6 directly, so that sequence would be invalid. Okay, so that's what a valid sequence is. Your task is to calculate the number of valid sequences and print it modulo this. Okay, so you are given a tree, you just need to find how many valid sequences are there in the tree. Simple. Okay, so the n is given as 3, 5. So you have to do it some order of n time or n log n time. Okay, so let's look what we need to do. So you are given some tree. Okay, some random tree you are just given. What you need to find out is the root of the tree is vertex 1. This is the root. Okay, you just need to find in this tree how many valid sequences exist. What are valid sequences? First thing is from the root, you can move to any vertex in the next level. First of all, for the depth part, you would divide this tree into levels. Okay, so whenever you do, you can do it, run a DFS traversal and divide and find the level of each node, level or depth, whatever you say. Okay, that is very simple in the DFS traversal. Just whenever you are moving to next vertex, just say that the level of the next vertex v is level of the vertex u plus 1. This way, you can just compute the levels. Okay, so that's the first thing. So first divide this tree into levels. Okay, so once that is done, okay, so this is the first level, this is the next level, this is the next level, this is the next level. Okay, I hope that is fine. Yes. Okay, so This maybe let's call this as level 0, level 1, level 2, level 3, level 4. Okay. So first I divided this tree into levels. Okay. Now how can I move? From the root, I can move anywhere in the next level. Okay. So all the nodes in the next level would be connected to root for sure. So you can just move to any node in the next level. But for the rest of the nodes, now once we are at level 1, you can move to any node in the next level which is not adjacent to this node. Okay. So in this level, there are 4 nodes. Among them, these 2 nodes are adjacent. So you cannot move to them, but you can move to these 2 nodes from here. Okay. Same way, if you are at this node, you can move to these 2 nodes from here. Okay. Now, if you, let's suppose you are at this node, then you can move to all the nodes in the next level except these 2. Okay. So from this node, you can move to these. Okay. And same way, if you are here, you can, in the next level, all of them are connected, so you cannot move forward. So what all would be a valid sequence? Let's say you start with here and end with the root only. That is also a valid sequence. So you can stop anywhere. Okay. So for a valid sequence, you can stop anywhere. That's one thing. So either one valid sequence would always be this. This would always be a valid sequence. You start with root and just stop there. Okay. What are the other valid sequences? You start with root and then move to any one of the nodes from the second level. Those valid sequences are there. Then, okay, so like you can just see like this. When you are at this, how many valid sequences exist? So from here, you can move to here or here. So you can see that you can run something like a DP here, that if you are at this node, what all valid sequences starting with this node are there. Okay. So your DP of X represents the number of valid sequences if you start at node X. Okay. So if you start at node X, how many valid sequences are there? That's the DP state I'm taking. So how would that be computed? Let's say you are at this node. So one valid sequence is just start here and stop here only. So that one valid sequence is also always there. Along with that, what are the other valid sequences? So from here, you can go to this node or this node. So you will say DP of this plus DP of this, all those sequences starting with this. Okay. So in that, if you just before that sequence, if you add this, then it would become the sequence starting with this. So from here, you can move to this, and DP of this will give the number of sequences starting with this. And DP of this would give the number of sequences starting with this. So you can say that DP of this node is this plus this. Okay. And plus 1. This DP of this plus DP of this plus 1. 1 if you start here and end here. Same way DP of this node would be DP of this plus DP of this plus 1. So this is my DP state, and what is my DP transition? Sorry. So my DP transition is DP of any node V is sum of DP of node U such that U is not adjacent to V plus 1. Okay. So this I can say is my DP transition. U is not adjacent to V, and U is just to the next level of V, that also. So depth of U is depth of V plus 1. Okay, so all those nodes just to the next level, whatever is the level of V. Among those, whichever is not adjacent to V, you'll add the DP of those nodes plus 1. That's your DP transition. This is like base case for, like, this would be only for valid for all the nodes starting from level 1. This won't be valid for the root, because for that you can take all the nodes. Okay, so you can just write your final answer, like you can start your DP from this only, just don't take DP of root. Okay, write the base case as like DP of these only. Okay, that is okay, that will handle. But what would be the complexity if you are using a DP like this? In order to compute this thing, how many U would be there? If you just write this transition like this, then what would be your overall time complexity? It would be all those nodes not adjacent to view, that may be many. So this may go something in order of n square overall, because these number of nodes, the transition may go up till order of n and overall order of n square. Like in general, when you do in DP, if you do some summation of all the nodes which are adjacent to V, then you get overall complexity of O of n only, because you get order of n plus m, the number of edges, and number of edges in a tree is n minus 1. So you get overall order of n. But here you are not taking the number of edges, but the inverse of the edges, you can say, which are not connected. So that may go n square. The inverse of the edges may go n square. So overall you may get order of n square if you are writing directly like this. So how do you optimize this transition a little bit? So what you can say is, how would you start computing your DP? You would start computing your DP from the lowermost level. Once you have computed the DP states of all these levels, then only you can compute the DP states of these levels. Then only you can compute the DP states of these levels, then this, then this. Okay. So you'll start computing your DP states from the lowermost level. Okay. So let's say when you want to compute the DP of this, all the DPs of the level just below that is already computed. So uh, what you can do is, when all the nodes of level 3 are computed, you calculate the sum of the DP of them. Let's say S3 represents the sum of the DP states. So DP of this plus DP of this plus DP of this plus DP of this plus DP of this. That's what S3 stores. Okay. So once you have computed all the DP, all these DP states, you can easily get the S3, sum of the all the DP states in level 3. Then you can write your transition like this, that DP of this would be all these DP states minus the DP of nodes adjacent to me. So when you subtract this thing, you get the sum of DP states which are not adjacent to me. Okay, and then to that you add a plus 1. So you change your transition to DP of V is, like, you can say whatever is the level of V, S, you can say the sum of the previous level. Okay, it's just S just denotes the sum of previous level. Okay, so I'm writing it S, sum of the previous level plus 1 minus the DP of all the U such that U is adjacent to V. So U is a edge from V, and depth of U is depth of V plus. Okay, so if U is an edge from V, then obviously depth of U would be depth of V plus 1 only. That's this. If you write this condition or not, it doesn't change. It doesn't affect your answer. Okay, so when you change your DP state to this, now you can see that your overall transition would be this summation for all the states would overall be the number of edges in the tree. So it would be overall n plus number of edges is also of order of n. So overall order of n, in order of n only you can compute this. Okay. But only thing is, normally when you write DP on tree, you'd write the DP in the DFS only. But here you need to, when you are writing the DP state, you need to know the sum of DP states of all the nodes in the previous level. So you would not move in the DFS traversal, rather you would just do a DFS and compute the levels of all the nodes, and then just store like this. What all nodes come in level 4? Store them, like you can take a vector of vector. So vec of 4 stores a vector storing the nodes in 4th level. Vec of 3 stores a vector storing the nodes in the 3rd level. So after running a DFS calculating their level, you can transform it in this form, and then run your DP starting from the lowermost level to moving up. Okay, so while writing your DP, just calculate the states like this. all the nodes in the fourth level, calculate the DP for them, then take their sum, then move to the third level for all the nodes in the third level, calculate the DP for them, take their sum, then move ahead to the second level, calculate DP, take sum. Okay. So when you move like this, in overall order of n, you can solve this problem. Okay. So I hope the logic is clear to you. We'll move to the code so you'll understand better how what I'm trying to say. How do you write the code for this? Okay. So first thing is I took the input. Now the input was given in the form of the parent array. So I took the parent array and then I made the adjacency vector. So adjacency. So I'm getting an input like this. So the parent of 2, parent of 3, parent of n. So from 2 to n, I'm assigning. So the pi that I get is the parent of I. So in my adjacency, I would assign I is the child of pi. So adjacency of I dot pushback I. So I hope that is okay. So I made my adjacency list. After that, I had initialized the level vector to which I assign n plus. So I assign the level 0 initially, and then I run a DFS to calculate the level of all the nodes. Okay, so in the DFS, I'm just calculating the level of all the nodes or the depth of all the nodes. So for all the values in the adjacency of x, level of I is level of x plus 1 DFS x. Simply, I would get the level of every node. Okay, once I got the level of every node after running the DFS, I initialize a vector, a 2D vector, which was stored from 1 to n. So for every level, what all nodes are present in that level. So vec I stores a vector denoting the nodes present in the level I. Okay, so starting from 1 to n for all the nodes, in vec of level I push vec I. Okay, so if the ith node belongs to whichever level, in that vector, I would be pushed. Okay, so this way I've constructed that. Now I initialize my DP vector. Okay, and I initialize a variable sum, which stores the sum of the previous level, which I was trying to say here. So my sum variable stores the sum of my previous level. Okay, so initially it is 0. For the lowermost, when I start computing from here, the sum of the previous level is 0. Okay, so for these nodes, what would be my DPs? DP of this node would be just 1 because there is nothing in the lower level. So if you store sum as 0, it would be 1 minus, it has no adjacent value. So it would be 1 only. So your base case would be computed automatically here if you just initialize the sum with 0. So if vec I is empty, okay, like I'm assuming there are n levels, but it may happen there are only less than n levels. So if for the initial starting with, I'm assuming there are levels from 0 to n minus. So I'm moving from n minus 1 to 1. Okay. One more thing, I'll not compute the DP of this level 0. I'll only compute till here. So my final answer would be, either I start from here and end here. So this 1 is there, and then the DP of this plus DP of this. Okay. So 1 plus the sum of the DP of the first level. So 1 plus S1, the sum of the previous level. This would be my final answer. Okay. So after computing my DP, 1 plus sum would be my final answer. You can see. Okay. So how I compute my DP from n minus 1 to 1. If my veci is empty, so for the higher levels which doesn't exist, so for the levels which doesn't exist, I just put a continue. Okay. So now when I start with the levels which exist, so this S is just, you'll see when I compute the DP states of this level, I'll compute their sum in the variable S. And then finally, I'll update my sum to S. So when I move to the next level, this is my updated sum of previous level. Okay, so in S, I'll compute the sum of my current level. Sum stores the sum of my previous level. Okay, now so for V in vec. So all the nodes present in the ith level, I'll iterate through them. Okay. And I'll update their DP of V as 1 plus sum. Okay. I'll write DP of V as 1 plus sum, and from that I'll subtract the dp of all the values adjacent to v. So for all the nodes adjacent to v, I'll do dpv minus equal to dpu. Okay, and I have to compute everything in modem. So whenever you do minus something, then you need to do modem plus and modem. Okay, I hope you know that. Okay, after that, in my sum, I'll just add up the current dpv. So in sum, I'll get the sum of the dp states of the current level, and I'll update the sum. So for the next level, the previous sum would be this current s. Okay, so this way all my dp states would be calculated, and my final answer is 1 plus sum, as I discussed before. Okay, so this is my final answer. I hope you understood the logic as well as the code. If you look at the time complexity, this is all input part, and this whole thing is done in order of n. And then this dp, this is running n times. Okay, like what is happening here? Initial for some of the levels, I'll just put a continue. Okay, so for all the levels, this loop, okay, this is just I'm iterating through vec I. So this whole thing is running n times for every node once. Okay, so this thing is running n times for every node once, and inside this loop, so this is running once for every edge. Okay, so this loop is running order of m times, or m is n minus 1, so number of edges in the tree. So this overall is running n minus 1 times the number of edges in the tree, and this whole thing is running overall whatever is the number of nodes in the tree. So overall the complexity is n plus n minus 1. Okay, so which is order of n. Okay, so or I'll write the time complexity there. So this is n plus n minus 1. So my overall time complexity is order of n. Okay, this is order of n. This is order of n. And my space complexity would be, so I'm just using an adjacency, which would be the total size would be n. And this level vector also has a total size of n. And this vec vector, the overall size, it is a 2D vector, but still it would have only n pushbacks in that. So the overall size of this also is n. The overall size of this dp vector is also n. So overall space complexity is also n. Okay, so I hope this problem is clear to you. Thank you so much for tuning in. Goodbye. Have a nice day.